Hi everybody and welcome to WySTACK. I'm Lars and I'll be talking about research foundations for computer science in particular, of course, as we are doing computer science here, but also more generally, because really in terms of research, computer science has a lot in common with other areas, as I'm sure you will be unsurprised to hear. You might have had some exposure to that already, and you might have had some research experience yourselves already. So we're going to talk a little bit about this as a general concept on a very abstract level, just to make sure that we're all on the same page when we talk about research and that we all understand roughly the same things there. Of course, we will not be able to go into a whole lot of detail because simply of a lack of time, and research, of course, being a very large and big thing on its own. But hopefully this series of videos will give you a little bit of a better understanding of what research in general and in computer science in particular means, how we're going to do this, the general principles and methodologies that we're going to apply, and hopefully also inspire you to then be able to take something back into your classrooms and have your students do something that is maybe not research, but at least goes in that direction. And the first thing I want to talk about here is really something that is very fundamental to all of our research, and that are hypotheses. Really, this is essentially the means by which we acquire knowledge and by which we advance the body of knowledge that is available for a particular area through research. We observe something, we build some model of how the world works, and that model can take very different forms. That could be an actual physical model, like a small house to see what happens when I throw water on a big house or something like that. And that could be an abstract model in your mind. That could, of course, be a computer program, a computer simulation, all kinds of different things. Now, these models are simplifications of something that happens in the real world that we're interested in a better understanding of. That could be lightning, for example. You observe lightning, and based on that, you build up a model that, okay, well, this seems to happen when there are big clouds and gray clouds in the sky, and rain somehow seems to be related to that as well. Based on these models, you can then formulate hypotheses. For example, if I see the black clouds, then I should expect lightning, which seems like a sensible thing to do. And in particular, then you can go and seek shelter and do anything else you might want to do to protect yourself from the lightning. So these hypotheses are very targeted and relatively small things. For example, as I said, gray clouds and rain, lightning. There are also things that we can actually test and that we can check whether they are true or false through some experiment that we design, or we might have to wait until we actually see a thunderstorm, maybe observe the rain without lightning. But it is something that we can check, and this we can then use, the result of such a check we can then use to further advance our knowledge. For example, our hypothesis might be that if there are gray clouds and rain, there's always lightning. And then we can check this by waiting until the next time it rains and there are gray clouds and observing that, oh, actually there was no lightning this time. Okay, so I guess my hypothesis was wrong. I've learned something. Great. And that's what we're going to practice now. I want you to come up with a hypothesis that is ideally related to computer science and computers in general, and really in the widest sense. So this could be something along the lines of, when it's warm outside, the battery of my phone doesn't last as long, or on this particular connection that I'm on, I cannot watch this YouTube video in the highest resolution. Or if I use this particular program for data analysis, then I know that I cannot do more than a gigabyte of input data, because anything bigger than that will crash my computer. So something very targeted and relatively narrow, but something that you can test, and something that will then hopefully help you to advance your knowledge and understanding of a particular process or a particular computational process in this context here when we're talking about computers, and that you can then use to maybe come up with further hypotheses or a refined hypothesis based on the result of your experimentation etc., etc. So try to do this, and this can of course be something that's related to what you're teaching as well. So you might not be teaching computer science, you might be teaching art or maths or something like this. Lots of hypotheses in these other areas as well. So think about something that might make sense there, that would be interesting, maybe not something that is utterly trivial and really, really easy to check because, well, okay, that might not be that exciting. For some further inspiration, have a look at the website in the additional resources for this video. There are 3 famous hypotheses there and what people did to test them, and maybe that can inspire you to come up with something similar, which you can then investigate later. So have a go at it and see how that goes.